Okay, today's class notes. So we want to solve radical equations. So just let's recall some radicals. So if we have an x with the index m, first let's understand what does this mean. So this means, let's say this equals to y. So equivalently, that's y raised by m equals to x. Okay. So we call this m's root of x. M is called index. Let's give an example. Let's see, we have square root of 3. So by default, this is 2. So if there's no number, the number is 2. So usually we write just square root of 3. So no, we don't put a 2 over here. So what does this mean? This means some number square to be 3. So square root 3 is a number. Okay, itself is a number. It's an irrational number. It's a new family of numbers. Irrational number. Irrational means it doesn't really make sense to human brains, right? Versus rational. Rational numbers could be like 1/2 or negative 1/3, right? So this, we can make sense of those. But square root of 3, we can approximate. If we press into a calculator, the calculator give us approximation. So no one really knows its exact value. So with m's root of x, sometimes if we could, we raise by m's power, especially when we solve equations. So you see this index is 2. So we're going to square both sides, right? Because why we do that? Because the index is m, now the power is m. Remember, I have rational exponents. So the power goes to the numerator, the index goes to the denominator. So now m divided by m, that's just 1. So x raised by 1. Usually we don't bother to write x raised by 1. We just write x. Okay, so we're going to use this feature for solving radical equations. So for a, we see the index is 2. So we want to raise by square. Square, so 2 over 2, that's 1. So we have 4x plus 1 equals to 1 squared still 1. Now we subtract 1 on both sides, right? 1 minus 1 is 0. We divide by 4 on both sides, so we get the x equals 0. 0 divided by anything would be 0, right? If we plug in 0 back into the equation, so 0 times 4, that's 0. 0 plus 1, that's 1. Square root of 1, that's 1. So the solution for A is 0. Well, now let's look for C. Then we go back to B, okay? So the index is 3. So M here is 3. So we want to raise by 3 on both sides. Right? The left-hand side raised by 3. 3 over 3 equals 1. So we get a 2x plus 7 raised by 1. Then negative 1 raised by 3. That's still negative 1. So we subtract 7 on both sides. We get 2x equals to negative 8. We divide by 2 on both sides. We get x equals to negative 4. Right? Now let's plug in negative 4. 2 times negative 4 is negative 8. Negative 8 plus 7, that's negative 1. Negative 1 cubic root, that's still negative 1. So it's a solution. Now let's move to B and D. B, we see the left-hand side square root, right? The right-hand side square root. So we just square both sides. Square root, right? This is square root. 2 over 2 becomes 1. So we have 2x plus a on the left-hand side. 4x minus 10 on the right-hand side. Subtract 2x on both sides. Right, get 2x. Then plus 10 on both sides. Get 18. Divide by 2 on both sides. X equals 9. 2 times 9, 18. 18 plus 8, 26. So we'll get square root of 26 on the left-hand side. 4 times 9, 36. 36 minus 10, 26. Square root of 26 on the right-hand side. So 9 is the solution. Now let's see D. D is different. Comparing to B, both sides will have, everything under the square root, so we could square. Now D, we have plus 2 here. So that means we have to square it twice, right? So we square the left-hand side. Left-hand side just have x plus 3. Now let's square the right-hand side. Right-hand side, we have 2 terms. We have this radical form, we have 2. Remember difference of 2 squares. If we have a minus b squared, that equals to a squared plus b squared, right? Square the first one, square the second one. Now minus 2 times ab, the middle term. So let's just follow that. So we have the first one square root of x minus 5 squared. This is x minus 5. Then minus 2 times 2 times the square root of x minus 5, right? Think of this term as a, think this term as b. Oh, we have a plus b. So this is a plus b form. I have a plus b form. Right, because you see we have a plus b form. So we got a squared. Well, a squared is just x minus 5. B squared is 2 squared, which is just 4. Then 2 times this term times 2. So 2 times 2 times radical x minus 5. So now let's simplify. So minus x on both sides, x canceled. Then we have this minus 5 plus 4, which is negative 1. Negative 1 on the left-hand side, right-hand side move to the right, become positive 1. 1 plus 3, we get a positive 4. Now we have 2 times 2, then radical. We have 4 radical x minus 5. Now we want to divide both sides by 4, right? The left-hand side becomes 1. The right-hand side, 4 over 4 becomes 1. So we have a square root of x minus 5. Now we have to square one more time to get rid of the square root sign. So now we square one more time. 1 square is 1. Square root cancel each other. Get x minus 5. Add 5 on both sides. So x equals to 6. Well, let's check. 6 plus 3, 9. Square root 9 is 3. We have 3 on the left-hand side. 6 minus 5 is 1. Square root of 1 is 1. 1 plus 2 is 3. Indeed, so both sides we have the same answer. So 6 is the solution for D. Now let's see, complex numbers. So remember, our number system start with a natural number. Natural number means counting numbers, right? We start with 1, 2, 3, so on and so forth, until infinity, right? This is natural number with addition. If we add any two natural numbers, that's still a natural number. Then, so that's only with addition. We can add things, but then we want to do subtraction, so we need integers. So natural numbers extended to integers. Now we can deal with the negative numbers. The 0 is the origin. Until infinity. So integers, we use z to represent. We can do plus, we can do minus, we can do addition, we can do subtraction. But then we want to do division. So we extend it to rational numbers, which means fractions. Which means we have p divided by q, right? P and q are integers. But q, the denominator, we don't want it to be 0. Rational numbers like 1/2, 2/3, -1/5, so on and so forth. But here now, rational numbers, we use q to represent. We can do addition, we can do subtraction, we can do multiplication, we can do division now. But then we have another family of numbers, like square root of 3, square root of 2. We call them irrational numbers, right? As your square root of 2, square root of 3, the infinite many. So all those above numbers, rationals, irrationals adding together, we call real numbers. Real numbers are defined as if a number multiplied by itself cannot be negative. It has to be at least 0. But then gradually, we have something called imaginary number. What imaginary defines is such I squared equals -1, or I equals the square root of -1. Okay, then combine real numbers and imaginary numbers, we have complex numbers. Complex numbers, we have a real part, we have an imaginary part. Real part is A, imaginary part is B. Okay, so we're going to use this definition for imaginary number. I equals to square root of -1 and I squared equals to -1. And then later on, we can find out that I cubed equals to I squared multiplied by I squared is -1, so we get negative I. And the fourth power is I squared times I squared. Well, it's a -1 squared, so that becomes +1. So I only has these 4 values, all right, by raising a power. The higher power can reduce by finding multiples of 4, because I to the 4th power is 1. Now with the complex numbers, so we have this A plus B form. We can add them, we can subtract them, we can multiply them, we can divide them. We can perform all the operations with real numbers for complex numbers. Let's see, this one we want to add. We have first complex number and second complex number. So when we add it, we look for like terms. So this number and this number are like terms, because both are real numbers. So 3 plus 4, 7. Now, imaginary part, we have 5 minus 7, right? That's -2i. So A, we get 7 minus 2i. That's addition. And we can do multiplication. We can multiply 3i with 4, 3i with -i squared. 3i times 4, 3 times 4, 12, so we get 12i. Then 3 times 6, 18, -18. Well, I squared is -1. That becomes +18. So we have +18 minus 12i. Plus, because positive, right? 18, -18 times -1 is positive. And 12i itself is positive, so 18 plus 12i. Now let's see C. C, we have 2 dimensions, 2 terms, well, 2 terms, so we FOIL it, right? We FOIL it. The top, we have 3 times 5, which is 15. Therefore, I times -3i. I times -3i. That's -3i squared. Well, that's +3. because I squared is -1. -1 times -3, +3. Okay. So here we get +3. Then lower end we have I times 5, give us 5i. 3 times -3i, -9i. Adding together, -4i. So the answer for this number is, we have this 5 plus this 3, that's 8. So the real part is 8. And the imaginary part is this -4i. Let's see D. Square root of -9, right? Square root of -9 is not in the real number. So we know square root of -1 times square root of 9, right? That's what it is. So we can split those two. And square root of -1 is I, such I. So square root of 9 is 3. So this equals 3i. So similarly, square root of -4 is as 2i, because -4 can be split as -1 times 4. Square root of 4 is 2. Square root of -1 is I. So I have 2i. So now we have 3i times 2i. 3 times 2 is 6. I times I squared. Well, I squared is -1. So we get -6. We can also divide complex numbers. Let's see 8. So when we divide, we could think this way. We want to get rid of this I in the denominator. So we want to multiply by I divided by I. By doing so, the denominator will get a 2i squared. And we know I squared is -1, right? So we just get -2 in the denominator. Then I times 4, that's 4i. I times 3i, I times 3i equals 3i squared. What's I squared? -1. So get -3. Right? Okay, so 3i times I, -3. We want to write the real part first. So now, -3 divided by -2, those two, that's +3 over 2. Minus 4i, positive divided by -2, is -2i. So the real part is 3 over 2, the imaginary part is -2. Now let's see B. B, we have a binomial, basically. We have real part, and we have the imaginary part. So we want to multiply by its conjugate, 5 plus 3i. By doing so, these two middle terms get cancelled. Because one way we multiply, we get -15i. The other two, we get a +15i. Adding together, that's 0. So we just have the denominator, we have 5 squared minus 3i squared, right? Well, let's finish the denominator first. 5 squared, 25. 3i squared, 9, -9. -9, this is a minus. So that's +9. Basically, 25 plus 9, 34. Now let's go back to the numerator. So I have 5 plus 3i. If we want, we can put parentheses around. We do 1 times 5, which is 5. I times 3i minus 3, right? I times 3i, that's 3i squared. That's -3. Then the middle term, we multiply these two, get 5i. Multiply these two, get 3i. We want to add those two like terms, so we get ai. Right? The real part is 5 minus 2, which is 2. The imaginary part is just AI. Then all divided by 34, right? So 2 minus AI divided by 34. Well, we want to write as A plus BI form, real part, imaginary part. So we do 2 divided by 34, simplify to be 1 over 17. A divided by 34 is 4 over 17I. Now you see what our A is 1 over 17, or B is negative 4 over 17. So that's to divide imaginary number. So lastly, we have these two. We want to simplify. So I raised by 21. Well, how do we remember? We see I to the fourth power equals to positive 1, right? I equals the square root of negative 1. I square equals to negative 1. Negative 1. I cube equals to negative I to the fourth power equals to 1. So we want to use this property. So I to the 20, so we want to look for multiples of 4, right? 4, 8, 12, 16, 20, 24, 28, 32, 36, so on and so forth. So I to the 21, we want to break into I to the 20 plus 1, right? That's I to the 20th power times I. Well, I to the 20 is I to the fourth power, then again raised by 5 times I. Well, that's 1 raised by 5 times I. Or 1 raised by any number is still 1. 1 times I is I. So I to the 21st power, just I. Okay. So I has a period of 4. Now this one, same thing. We're looking for, we want to break into I raised by 32, because 32 is a multiple of 4, times I squared, right? 34 is equals to 32 plus 2. Well, I to the 32 is I to the fourth power raised by 8 times I squared, just negative 1. Well, I to the fourth power is 1. 1 to the eighth power is still 1. 1 times negative 1, that's, oops. 1 times negative 1, that's just negative 1. All right, so we want to simplify, we want to reduce the I to the higher power. We'll basically use this property. I raised by 4 equals to 1. Okay, so that finishes today's class notes.